Welcome to another deep dive. If you're listening to this right now, I know exactly who you are. You're that endlessly curious learner, the one who's always hunting for that crucial aha moment to take into your next big project.
Yeah, you're the one trying to fix things.
Exactly. Maybe you're prepping to lead a massive meeting later today, or perhaps you're just trying to wrap your head around a massive enterprise initiative that feels like it's completely stuck in the mud. You need that one perspective shift that changes everything. Well, you are in the right place today.
Because today we are talking about a scenario that plays out in almost every major company on Earth.
Right. Picture a massive tech modernization project. We're talking huge budgets, really tight deadlines, sky-high expectations from the board, and then maybe a few months in, it just hits a wall. Progress crawls to a halt.
And when that happens, the immediate reaction from the outside is always exactly the same. Everyone points the finger at the technology.
Oh, always.
They blame the spaghetti code. You hear complaints about, outdated legacy platforms, monolithic architectures, or those brittle ancient integrations that seem to crash if you just look at them the wrong way.
Right, like if you breathe on the server, it goes down.
Exactly.
Yeah.
The assumption is always that the underlying tech is simply too convoluted to untangle.
The instinct is to say the code base is the enemy. But what if we've been misdiagnosing the illness this entire time? Today, we are pulling from a really fascinating stack of sources to flip the script on legacy modernization.
We've got some great material today.
We do. We have a thought-provoking article from March 9th, 2026, written by Suyash at Codora, and it's titled, "Modernization Isn't a Technical Problem, It's a Knowledge Supply Chain Problem." And we're pairing that piece with Codora's detailed technical documentation on their actual modernization framework.
Which gets pretty deep into the weeds in a good way.
It really does. So our mission for this deep dive is to uncover why adding more engineers to a stalled IT project is often the absolute worst thing you can do, and how treating your company's institutional knowledge as a literal supply chain completely changes the paradigm. Okay, let's unpack this. Where are these bottlenecks actually forming if we can't blame the legacy code?
Well, the reality is that modernization delays almost always happen before a developer even opens their IDE to write the single line of new code.
Wait, before they even start typing?
Before they start typing. The friction is informational, not technical. Think about what a specialized engineering team is actually doing when a massive project stalls. They aren't typing, they aren't building, they are waiting.
For what?
They're waiting for someone to explain why a specific module was designed a certain way 10 years ago. They're waiting for clarifications on incredibly obscure business rules that aren't documented anywhere.
Oh, wow.
Yeah, or they're waiting for approvals from senior architects who are themselves deferring decisions because nobody is entirely confident about how the legacy system actually behaves in production.
So it sounds like progress halts because the team's understanding of the environment is fractured rather than the environment itself being inherently unchangeable.
That is exactly it. And that introduces the central concept from Sugash's article, the knowledge supply chain.
The knowledge supply chain.
Right. Every legacy system operating in the world today is supported by this invisible supply chain. It consists of the people who hold the historical context, the artifacts.
Like wikis and stuff?
Yeah, wikis, system diagrams, specification documents that supposedly describe the system's behavior, and also the internal processes that move that context from one department to another. When that information flows smoothly, modernization is just a matter of execution. But when that chain breaks, the entire initiative grinds to a devastating halt.
I want to frame this for the listener with a slightly different scenario to make it really relatable. Imagine trying to renovate a massive 100-year-old house.
Okay.
You want to knock down walls, put in modern appliances, the whole works. But the only person who knows where the original plumbing and the electrical lines are hidden is a guy named Bob.
Bob has answers.
Bob has all the answers. But Bob is only available for 15 minutes a week. You have a house full of highly paid, incredibly skilled contractors, but they are terrified to swing a sledgehammer because they don't know if they're going to hit a water main.
That captures the sheer operational terror of enterprise modernization perfectly.
Yeah.
You have highly capable people paralyzed by a lack of context. And the sources we're looking at identify 3 predictable fractures where this knowledge supply chain snaps under pressure.
Can I bet my Bob analogy hits on the first one?
It points directly to the first one, which is SME dependency, subject matter experts. A microscopic fraction of the workforce holds a disproportionate amount of system understanding right in their heads.
We lean so heavily on those few veteran engineers, they literally become a single point of failure for knowledge.
They do. Their personal availability dictates the pace of the entire enterprise. A modernization program with 100 developers might be entirely bottlenecked by the calendar of 2 senior architects.
That's a huge systemic risk.
Immense. When those key individuals become overloaded or they take a vacation or they retire and leave the company, the supply chain is severed. And as the article points out, in the absence of hard facts from those experts, delivery teams just start substituting dangerous assumptions to keep the project moving.
Which usually leads to massive outages down the line because they guessed wrong.
Exactly.
But companies know this is a risk, right? Which brings us to the second major fracture, artifact decay. Usually when leadership realizes they have a Bob problem,
SME bottleneck.
right, they commission a massive audit. They bring in armies of business analysts to write up extensive documentation on how the system currently works. But there's a fatal flaw in that approach, documentation drift.
Yes, the fatal flaw is that documents are static, while enterprise software is a living, constantly evolving entity. The analyst might spend 6 months creating a pristine library of system behaviors, but the moment those documents are finalized, the underlying code continues to change.
Because the business doesn't stop.
Exactly. Hot fixes are applied, new features are rolled out, minor tweaks are made in production to handle a crisis.
So within a few months, those really expensive documents no longer reflect reality.
Sometimes within weeks. And the psychological impact on the engineering team is severe. Once a developer references a wiki, follows its instructions, and realizes the architecture it describes was deprecated 2 years ago, that entire repository of artifacts loses its credibility.
They get burned once and they're done.
Right. The team simply stops trusting the documentation altogether. They revert right back to hunting down the original developers to ask them how things actually work.
And we are right back to relying on Bob.
The knowledge defaults back to human memory.
Okay, let's assume an organization somehow manages to keep their SMEs available and their documents relatively updated, which is a miracle in itself.
A rare miracle.
They still have to contend with the third fracture mentioned in the sources, handoffs. Enterprise modernization isn't a single event. It's a phased life cycle.
It's a massive, high-stakes game of telephone. Work typically moves from an initial discovery and assessment phase over to the build teams, then to quality assurance and testing, and finally to operations and deployment.
And context degrades at every single transition point.
At every step, the assessment team builds a deep mental model of the system's quirks, but they can only capture a fraction of that nuance in the requirement tickets. The build team interprets those tickets through their own lens, often completely missing the original intent.
Then the testing team has to write test cases based on an already diluted understanding. By the time the modernized system reaches the operations team, they are handed a black box. They have almost none of the original context about why certain architectural compromises were even made.
And that partial understanding is fundamentally insufficient for confident decision-making. You end up with a modernized system that technically compiles, but it fails to meet the actual business needs because the nuanced why was lost during those handoffs.
Now, I want to take those three fractures, SME dependency, artifact decay, and handoff degradation, and place them inside a highly regulated industry.
Oh, the stakes go way up.
Way up. I'm thinking of global banking, healthcare, or insurance, where the consequences aren't just a delayed project. You're looking at massive regulatory fines.
In regulated enterprises, this goes from being an efficiency drag to a massive operational risk multiplier. Compliance logic isn't usually sitting in a neat, well-labeled folder. It is deeply embedded in the historical behavior of the legacy system itself.
Right, wrapped up in 20 years of code.
A specific data validation rule might exist because of a regulatory mandate from 2012. When the context behind that rule is lost to artifact decay or a retiring SME, risk and compliance teams are left flying completely blind.
They have to manually reconstruct the history of the system just to prove to auditors that they are still compliant.
It turns audit preparation into a grueling archaeological dig. Teams literally spend weeks reverse engineering old code just to trace data flows and explain their control frameworks to regulators.
And the Codora article actually has a term for this. They call it generating fragile evidence.
Fragile evidence, yes.
Because it's based on temporary human interpretation, meaning they have to recreate that evidence all over again for the next audit cycle.
And this creates an environment of intense fear. Teams become so terrified of triggering a compliance violation that they actively avoid making necessary architectural changes, or they layer on clunky, excessive controls to compensate for their own uncertainty.
So faced with a stalled, fearful project, the standard corporate reaction is almost always to just throw more bodies at the problem. They misdiagnose the informational friction as a capacity shortage. They hire 50 more developers or bring in another massive consulting firm.
If we connect this to the bigger picture, scaling engineering capacity without concurrently scaling system understanding is a guaranteed recipe for failure.
It just makes it worse.
It is the core scaling paradox of modernization. When the demand for context outpaces the supply of that context, overall throughput completely collapses.
Because adding more developers who don't understand the legacy environment just creates 50 more people who need to ask the same SMEs the exact same questions.
You invoke Brooks's law, but on an informational level rather than just a communication level, you've widened the bottleneck without increasing flow.
You also multiply your dependencies. Launching more parallel work streams with developers who lack context massively increases the chances of someone breaking a shared service.
Exactly. When knowledge doesn't scale, enterprises are forced into terrible strategic trade-offs. You either intentionally slow the whole program down to wait for certainty, which delays your time to value, or you forcefully push forward based on blind assumptions.
Which drastically increases rework, defect rates, and operational risk. You end up with an organization that burns a tremendous amount of capital, feels incredibly busy, but produces very little actual value.
This requires a massive philosophical shift for leadership, specifically for COOs and delivery executives.
How so?
If you're leading a transformation, you have to stop looking at raw utilization metrics. You can't just look at a dashboard of closed Euro tickets and assume progress is being made. The article argues leaders need to start measuring the throughput of understanding.
Throughput of understanding, I like that.
You have to evaluate whether your teams actually possess the context required to make safe, accurate decisions today. It demands treating system intelligence as a managed critical asset. You have to ensure that knowledge moves through the organization faster than the code itself is changing.
Here's where it gets really interesting. Because diagnosing the disease is one thing, but how do we actually cure it? How do we fix a broken knowledge supply chain without just throwing more analysts at the problem? Let's pivot over to CodeAura's technical documentation.
Let's do it.
We have heard promises of tools that, quote-unquote, auto-generate documentation for years, and they usually just spit out useless, unreadable code maps that developers ignore anyway. How is CodeAura's approach actually different from those failed legacy tools?
The skepticism is completely warranted because traditional tools only provided syntactic mapping. They could tell you that module A called module B, but they couldn't tell you why.
Just the what, not the why.
Right. CodeAura's solution, which they call system intelligence, operates fundamentally differently. It doesn't rely on human memory, and it doesn't just map syntax. It uses deep semantic analysis of the actual code base to automate a structured knowledge layer.
What does that mean in practice?
The granularity of this framework is what sets it apart. It operates simultaneously at multiple levels of abstraction, giving you the 30,000-foot system view, the architectural folder view, and diving right down into the specific file-level logic.
Walk me through what that actually looks like for a developer sitting at their desk staring at a massive, undocumented legacy application.
At the most granular level, CodeAura analyzes an individual file, say a massive ancient COBOL program or a really complex Java class, and instantly generates a high-level natural language summary of what that file actually accomplishes in the real world.
So not just code jargon.
No, it goes beyond the code to provide function-level explanations. It translates dense, esoteric legacy code into highly readable pseudocode. It systematically maps out exactly what inputs a specific function requires, what outputs it guarantees, and critically how it handles edge cases, error states, and validation logic.
So a developer doesn't have to spend 3 days manually tracing variables through thousands of lines of unfamiliar code just to figure out what a single component does. The code base is essentially explaining its own behavior in human-readable terms.
It completely ends the era of guesswork reverse engineering.
Yeah.
It immediately answers the fundamental questions of what a component does and how it processes data. Without that automated semantic layer, every modification to a legacy system is just a high-risk gamble.
I want to highlight a crucial nugget from the technical docs for the listener here, especially if you're managing business-critical applications. CodeAura doesn't just map the plumbing. It specifically extracts deeply embedded business logic.
Which is huge.
It is the absolute lifeblood of an enterprise. The complex pricing tiers, the intricate transaction workflows, the hard-coded approval hierarchies, and the compliance rules we discussed earlier, all that stuff hidden in the code.
The extraction of business logic is vital because of a concept called functional equivalence.
Functional equivalence. Let's break that down.
When you undergo modernization, the underlying technology stack can and should change. You might be migrating off an on-premise mainframe and rebuilding the application in a modern cloud-native environment using microservices. But the business rules themselves must survive that transition perfectly intact.
Right. If your legacy system applied a very specific, historically grandfathered discount to a certain tier of enterprise customers under highly specific market conditions,
Your new cloud-native system must replicate that exact behavior.
you can change the how, but you cannot change the what or the why without impacting the business.
Exactly. By surfacing this business logic automatically from the source code, CodeAura allows teams to preserve the exact functional equivalence of the legacy system without relying on a SME to remember a rule they coded a decade ago.
That covers the individual files and the business rules, but we talked earlier about the danger of brittle integrations. Enterprise systems are rarely isolated. How does this framework handle the broader architectural picture?
It directly targets hidden dependencies, which are the absolute landmines of legacy modernization. In older monolithic systems, modules are often tangled together in ways that completely defy logic. You have services relying on shared libraries, obscure database connections, or undocumented cross-system API calls.
And usually, teams only discover these hidden dependencies the hard way. They update a specific service, deploy it, and suddenly an entirely unrelated billing system crashes on the other side of the company.
The blast radius of a small change is entirely unknown until it's too late.
Yeah, you touch a button in HR and the cafeteria registers stop working.
Exactly. CodeAura mitigates this by automating dependency mapping. It analyzes and visualizes exactly how components interact across the entire enterprise ecosystem. Before a developer even checks out a branch of code to modify it, they can see a comprehensive map of what might break.
That is incredibly powerful.
They know exactly which downstream services depend on the function they're touching, and everywhere a specific piece of database architecture is utilized.
Having a clear map of the blast radius before you make a change completely de-risks the build phase. And the way CodeAura presents this information seems like a massive leap forward. We aren't just talking about generating massive text files here.
No, it's highly visual.
They generate visual documentation, interaction diagrams, system flowcharts, component architectures, all rendered directly from the live code analysis. If you're a delivery leader trying to onboard a new cohort of engineers, handing them an auto-generated, accurate flowchart of data pathways is infinitely more effective than handing them a 1,000-page Word document from a 2018 audit.
It fundamentally transforms the onboarding experience. New engineers can rapidly grasp system behavior and architecture without needing to drain the calendar of your most valuable senior SMEs,
Leaving Bob alone to actually do his job.
letting Bob work. But perhaps the most transformative element of this entire framework is how it solves the problem we discussed earlier: artifact decay.
Documentation drift. The reality that the moment you write something down, the code evolves and makes your document a liar.
Traditional documentation is inherently passive. It sits in a SharePoint repository and slowly rots as the production system changes. CodeAura flips this by creating what they call living documentation.
Living documentation.
Because the documentation is continuously generated directly from the source code itself, whenever the underlying code changes, the documentation updates automatically.
Automatically. No one has to go in and manually edit the wiki.
Right. The architectural diagrams, the dependency maps, the business logic summaries, they all stay perfectly synchronized with the reality of production. Documentation drift is mathematically eliminated. The artifacts remain a permanent, reliable source of truth.
Which means the knowledge supply chain finally becomes a self-correcting mechanism. But they take it one step further by turning this living documentation into an active knowledge interface using AI.
This represents a massive leap forward in developer experience. The documentation isn't just a static wiki page you have to manually search through. It functions as an interactive system. You can engage with the codebase using natural language queries.
You can literally ask the AI, explain the validation steps in the customer onboarding flow, or where exactly is the European tax logic applied in this transaction sequence.
Or you could ask, which external payment gateways depend on this specific database table? The AI retrieves the answers instantly, drawing its conclusions directly from the continuously updated generated documentation and the live code analysis.
It's acting like a co-pilot that actually knows your specific enterprise system.
Yes, it shifts the entire burden of understanding. You are no longer relying on the fragile human memory of a few veteran experts. You are interacting with an accessible, highly queryable institutional memory.
So what does this all mean? If you're an executive preparing to champion a massive IT overhaul, or an architect trying to navigate a labyrinth of undocumented legacy code, the core takeaway from these sources is incredibly clear. You cannot successfully scale a modernization effort if you do not scale understanding first.
That is the bottom line.
Throwing more engineering capacity at a fundamentally informational problem without fixing your knowledge supply chain just buys you more waiting, more rework, and significantly more operational risk. Knowledge must move faster than the code.
Absolutely.
By automating a living documentation layer, you preserve your critical, hard-won business logic, you map your hidden dependencies before they cause outages, and you turn an opaque legacy system into a transparent, self-explaining environment. You finally empower your engineers to do what they actually do best: build the future instead of spending all their time reverse engineering the past.
This raises an important question, one that goes far beyond just accelerating IT projects or improving developer efficiency.
I love a good philosophical term. Where are we going with this?
If an AI platform like Codora can perfectly extract, map, and continuously update a company's entire historical decision-making process, if it can hold all the deeply embedded business logic and perfectly explain the architecture on demand, who does the institutional memory actually belong to now?
Wow.
As enterprises rely more and more on AI to explain their own legacy systems back to them, does the algorithm eventually become the true subject matter expert? And if the AI holds the ultimate context, do human engineers eventually become merely the operators of its understanding?
That is a staggering thought to leave on. If the system understands itself better than we do, the entire dynamic of enterprise architecture changes. Thank you to everyone for joining us on this deep dive into the knowledge supply chain. Keep asking the big questions, take these insights into your next massive project, and as always, stay curious.